That looks good. All right, great. Yeah, so due to the fact that there are such a large number of sites available, it's a bit onerous to have to scroll through this entire list. And so there's a feature of the event outlook. If we come to the top, we've elevated the most active sites to the very top of the list. And so at a glance, you can see here, these are the most active sites, the sites that have the most alerts across the entire time frame of the data that we currently have. As we scroll through time, it affects the rest of them. So right now I'm just doing a high level overview of the 3 sections, so more on that later. The typical user flow, having looked at the event outlook and having identified that there are some situations occurring that require review, we could come up here to the regional review and the regional view and take a look. These maps are all dynamic. They're populated with live data. As the data refreshes once every 5 minutes, the maps, every graph, every map, as well as the event outlook is automatically refreshed to represent the latest data. And there are several ways of looking at the map. And here we're gonna try and hone in on some events. You can see this is really quite a large alert over here, and it's unreasonably large because of the way we have it configured currently, and I'll demonstrate that in a couple of minutes. For the purposes of the demo, we wanted to make a dramatic circle. So you can look at a regional view. Looking at the map, you can pan and zoom, look around. There's also this is an entire regional view. We also can open up, spawn these smaller maps to view details of a specific region. When you're viewing these details, you're going to look around for a while, and eventually you're going to find some sites of interest. And when you find sites of interest, if any are alerting currently, you would want to look at those sites over here in a graph. So when you click on a site or when you click on a region, not only do you see a regional map when you click on it, but you see regional graphs as well as site-specific graphs. And so in our typical user workflow, this is step 3. So step 1, you notice some events. You don't know what they are. You just see that there are some. You come over to the maps. You search around visually identifying the locations of interest. Once you've identified those locations of interest, you move to step 3, which is the forecast panel. And here's where we see the actual details. And so looking at the forecast panel gives you access to the entire time series of data, as well as the raw data coming in from the forecast, as well as data calculated by RAVIS, which is essentially the alerts. And so we have algorithms in place to identify certain ramping events based on changes in forecast power generation across segments of time, which is what we're looking at currently. It's what these orange, the pink vertical lines represent. Just checking my notes real quick. Right, so the event outlook panel, diving into some details now. The event outlook panel is very simple. Honestly, I've already described almost all of the features. It shows all the sites, it shows all of the time series, and it has a little yellow dot where unalert. The dots don't represent a severe alert or a mild alert. They simply represent an item of interest. There's also the time slider resides here. The time slider is useful because it allows you to navigate through time. And so if you want to view data, forecast and alerts at multiple time steps, you can move around here and you can see what's coming in the future. I think it's also worth noting that the way RAVIS is written, the data we currently have doesn't include historical data, past data. There's nothing, the code is written in such a way that it would be totally possible if you feed in a time series data set that includes, the past 6 hours of data or all of yesterday's data, it would show up here just fine. And you can navigate back and forth across that timeline in the same way that we're navigating from 0 to 6 hours ahead of us in this timeline. I don't know if you saw that glitch. The software just hit its interval and it just reloaded all of the forecasts from the server. In our instance, since it's static data, nothing has actually changed in the forecast data. We expect that, but in a real production instance, you would have expected to see the latest forecast, so it's updating every 5 minutes. Therefore, we would see 5 minutes would have dropped off the left side and a new 5 minutes would have been added onto the right side. So yeah, the event pane, fairly simple. The time slider allows us to navigate through the full time series. The regional views, the geolocation panel. So all of these views include Dots locating each point on the map. They include a triangle icon if an event is present for a given region or a given site. The triangle icon indicates not only that there's an event, but if it's pointing up, it represents an up ramp. If it's pointing down, it represents a down ramp. The same is true for the sites on the detail maps, as is true for the locations on the overall points on the regional map. And what we're seeing now is, because of the way it's configured, is that while there are alerts that are being triggered at the regional level, there are no alerts being triggered at the site level. And there's a reason for that, and I'll demonstrate that in a few minutes. When you hover over a point, this is worth noting, when you hover over a point, it gives you information about the point in detail. And so right now we have a very small amount of metadata relating to each of these sites in this demo data. And so it shows that this is a site named Van Horn 1. It has 0 megawatts of total capacity, which can't be right. It's just a metadata error, and the ramping is nominal. This data, depending on the richness of your data set that you feed into RAVIS, this could show a much wider variety of data in these pop-ups. And so it really, whatever data you feed into it, it would show here. And so this would be very useful if you wanted to show more information about, market factors, more information about the sites themselves, any type of, if you know that there's curtailment scheduled for these or maintenance outages scheduled for these, like any kind of information that was useful to your business, you could place in here quite simply. The system is built to handle that type of thing. Likewise, on a regional level, we have the same type of metadata that's available. And like I said, the maps have all the normal features. You can pan, you can tilt, you can zoom either with a scroll wheel or with a keyboard. And so as we zoom in, we see more and more data showing up about the details of these sites. So that's the geolocation panel. You can close the geolocation panel items, and you can open them up by clicking. And so you can have as many open as you wish. When you open too many to fit in the available space, it starts scrolling. And so in this case, I've got all 5 open, and you can see it requires me to scroll a little bit to see all of them. And if I'm done looking at one, I can simply close it out, and the panel will reorganize itself to better fit all of the maps within the smallest amount of space possible to minimize scrolling. And so that's the geolocation panel. Once again, I'm just going to review my notes really quick to make sure I didn't miss anything. I think Venkat mentioned, I didn't point out specifically this time, the halo size is the indicator of the severity of the alert. And so this is where we start to get our first indication of some details visually speaking. We also have done work, nothing that I have available to demo today, but you can have multiple types of visualization for multiple types of data. And so if you had different types of alerts, perhaps a curtailment event could be considered an alert or an event, and you could add that here, and you could add it to the map, and you could assign a custom style to those type of alerts, so that you would have, a yellow triangle with a yellow circle around it, and maybe a green halo or something like that, indicating that the system is healthy, or an orange halo indicating that it has some kind of curtailment event or something like that coming up. And so the map is really quite dynamic in the possibility for visualization of a variety of data. Okay, so moving on to the third panel. So this is the forecast panel. Here we see the specific time series data, both for a region and for a specific site. The heart of this, again, it's a time series. And so at the bottom, we can see the time frames assigned. We're going from 9 a.m. till a little bit after 3 p.m. This aligns with the time frame on the slider at the bottom. And so you can see, if I move the slider around to different points in time on the bottom, not only is the map updating, but likewise, each of these graphs is defaulting to that time. However, if I hover over the map, I can, over one of these graphs, I can more easily move just by moving my mouse back and forth across it, you can see the detailed data relevant to that time slice of the forecast. And so that is showing up at the very top of the graph. Right now, you can see it says Events, none at this time slice. The mean power is 90 megawatts at this time slice. The upper 95 percentile is at 99 megawatts. The lower 5% percentile is at 81 megawatts. So those are the forecast details for the time slice that I'm hovering over. Likewise, the graph itself represents the thick yellow line is the mean forecast, and the thinner yellow band, or the more faded yellow band, is the entire width of the probabilistic forecast, ranging from the lower 5th percent to the upper 95th percentile of probability. These numbers are kind of called out via these horizontal lines, and so it's simply showing the minimum value is a 7 megawatt minimum value, which if you follow the line, you can see it happens way down here in the morning. Kind of makes sense, talking about solar data. Sun tends to be lower in the morning. And then likewise, the forecast maximum occurs here at the end of the day, or in this case at about 3:30 p.m., which is after the solar eclipse had ended and the sun came back out again. And then this line represents the total capacity. So the capacity of this facility, or in this case, since it's a regional view, this is the total capacity of the region, which is simply the sum of all the sites in the region, just as these forecasts are simply the sum of all of the forecasts of the sites in that region. Another feature of this graph panel that's kind of cool, there's a little zoom button, and essentially, you know, the graph is a little skinny. The information isn't visually compelling. If I hit the zoom button, it highlights the active range of the data a little bit more and allows us to see a finer grained view. This view always scales the graph relative to the size of the region or the size of the site specifically. And I think that, you know, the idea of that is that if it allows you to tell at a glance, you know, across the entire capacity of that site, where is the solar forecast? And so here, if this is the maximum total capacity, we can see that our region is kind of hitting its middle capacity, and here it's reaching closer to maximum capacity. But like I said, with the zoom button, it allows you to see just the data, slightly finer details of the data itself. Similar to the maps, I can close these out. The more I close out, the panels adjust themselves. If I have a bunch open, as I do, you have to scroll up and down to see them all. If I close enough out, eventually the scroll disappears and we're left just with the graphs that we have. And so we can open another one. We can open another one. See, the different sites have different forecast values. This one's zeroed out. So let me close these out and open up something that's got some alerts happening. Okay, this one has constant alerts. So this is probably, you know, not configured correctly because this is really a lot of ramp events. But what I wanted to demonstrate was that in the case of an event, the events are shown as a vertical pink line. And as I hover over it, you can see in that upper panel, it now says there's an event, an up ramp by 42.14 megawatts. And that is the information about that event. And so essentially, this is the basic core functionality of RAVIS. This is the features we anticipate users would be using constantly throughout the day, observing this, monitoring it, using it to explore situations, imminent or otherwise. However, there are a lot of capabilities for tuning this view, and so for making it more interesting, and that's basically what we have on the settings page. So we designed RAVIS to be configurable in two ways. The first way that RAVIS is configurable is, I already touched on this a bit, but you can configure it when you deploy it. You can configure it with the data sets that you want to ingest, the interval at which those data are updated, the number of sites, the location of those sites, the metadata associated with those sites. All of those values are configured at deployment time. And so they're not dynamically alterable, but of course you can update, you know, configuration files on the back end, and that will change how RAVIS loads by default. In addition, however, we wanted to support dynamic changes. So during day-to-day use, you might want to come in here and switch things around a little bit. So the first thing, starting over here, you can toggle between different data sets. So currently we have the sample data with the eclipse and the sample data without an eclipse. And so this is two separate data sets that are really very similar. In a production site, we would imagine you might have 3 or 4 or 5 different data sets that you wanted to toggle between. And we imagine that they would probably not be analogs of each other, but would be, distinct and valuable data sets. So having toggled, if we hit save and we go back, we can see essentially the same data stream, but now there's no eclipse. So it doesn't dive down just around 2 o'clock. It's a flat line as you would expect the sun to be on any normal non-eclipse day. We also can change the ramp thresholds. And so, as I mentioned earlier briefly, a ramp threshold is defined by a certain amount of change in power forecasted across a certain period of time. And so currently we have a global default set at 13 megawatts, which, since nothing else is defined specifically, that global default will become the event threshold for all regions and all sites that are being displayed in RAVIS. And so if I change it to something like 1, a very unreasonable value, but you'll see the way it impacts the map is now lots and lots of sites are alerting. The alerts relative to regions are huge in the event outlook. It's just all events all the time here. And so obviously this is an extreme case. And so we could go in the other direction. And if I change the default to a change of 100 megawatts between time slices of data, and we save that, now we can see there are no events. There are no events anywhere, right? So, and if you can see from this data, it's a pretty nominal line. There's not a lot of what would typically be considered an up or a down ramp happening. And so in addition to this global default setting that can be applied across the board, we can also define a regional setting. And so if I only define a value here, then that value is applied not only to CAISO region 1, but also to all of the sites that belong to that, Agua Fria, Alamogordo, et cetera, et cetera, et cetera. In addition, I could also define as fine-grained as I want. So I could come in here and simply define threshold values for each site individually. If I wanted to. And if I only define some sites, then the rest of them will pick up the regional default. If no regional default is assigned, they'll pick up the global default. So if we save that, we'll see, okay, we defined a custom value for that region. So we're seeing some regional alerts, but we're still not seeing site-specific alerts. So that's the ramp threshold configuration. The final configuration option that's available to us is, I mentioned this again before, there are custom regions. And so if I had some sites of interest that I wanted to view as a region together, I could create them simply by coming in here and choosing a few sites. And having done so, if I save out, now we can see a 5th region, which actually is so close to this other region. But here it is, my test 1 region, 18 megawatts total capacity. If I click on it, its map will show up. I can get it to zoom. Here it is, test 1. Here are the 3 sites I chose. If I click on them, so it has all the functionality of a built-in region, including showing a regional forecast or a site-specific forecast for any of the sites within that region. And that covers the configuration page. These are sort of the dynamically alterable properties. Once again, I'm just going to review my notes for a second, make sure I didn't miss anything. Yeah, okay. So that concludes the demonstration of this version of the viewer. So before we move into Q&A, I did want to take a minute to have a look at, this is the viewer showing the net load forecast. It has some proprietary data. It has a slightly different style. So we skinned this one slightly different for public release than this one has been skinned. But otherwise, the functionality is more or less the same. And so what we're viewing is a net load forecast that was created at NREL as part of this project. And you can see here a slightly different display. So in addition to simply showing, point data as sites, what we're showing here are nodes and transmission lines. And so I wanted to show just another example of how, as we discussed, with a different data set, the application features are still relevant. You still see a hover over, you still see whatever metadata was associated with those nodes and generators, but the data is different, and this is simply because the metadata that we're feeding into it is different. Similarly, on the graph, we can see we've got a different view here. So we still have our probabilistic forecast value, but we also are graphing the upward flex and the down flex from the load forecast. And in addition to that, we show, a traditional probabilistic forecast up here. And so this is a really interesting data set, and to more properly explain how this might be useful, I'm going to hand the microphone back over to Venkat for a moment.
Okay, thanks, Paul. What we are here showing here is, in addition to solar forecast, right, which is sort of input data, but we have market clearing tools which will consume this solar forecast, and then we have the market clearing solutions of generation schedules, right, transmission flows, and all of that. So essentially, what we're showing here is we can also feed in that data, sort of have more comprehensive situational awareness here. So what we are seeing here is, not all the alerts or all the ramp alerts for a net load may be severe, right? If you have enough generation flexibility, then it needn't be an alert, right? We don't need to send out too many alerts to operators. So that's essentially what we see here from the San Diego net load forecast time series, right? What we have there is the probabilistic net load forecast with the mean and the max and minimum bound, 95 percentile and 5 percentile bound. And then we see that there are plenty of ramps happening here and there, right? For instance, right in the morning around 9 a.m., there is a ramp down and then ramp up. And then even in the afternoon, there's a small ramp up and ramp down. But what we also see is the orange line enveloping the probabilistic net load forecast. And that orange line essentially is the available flexibility from the generation. So essentially, this is the output that we get out of the market clearing process. And we see that most of the times we have enough upward and downward flexibility, right? So actually, any ramp situations can be confidently met. But you also see that there are some times, for instance, 11 a.m. there's some shortage of upward ramp, even though we have enough ramp on the upward direction to meet any uncertainties. But if it is very extreme uncertainty, one has to be cautious. So it's a good insight for a system operator. Similarly, on the downward side, as we see, as the day progresses, right, we have solar power increasing, ramping up, and then the net load is ramping down. So that's why we see the downward flexibility is reducing and reducing. And at some point, it so happens that many of the conventional generators are at their minimum generation, right, min gen, so they're not able to move further down. So the available downward flexibility is actually lacking. So in those situations, one might expect renewables to be curtailed, right? So these are some insights that one might get from a comprehensive situational awareness, including other data.
Thanks. Great. So I just wanted to take another couple of minutes. So this is the viewer, this is the tool, and this is what it does. What we have recently been able to do is to make this available freely to anyone who would like to use. And so I'm going to take just a couple of minutes to show you how to get access to the source code and some resources that you could use if you were interested in trying RAVIS out in your own infrastructure. And then after the meeting, I'll still be able to spend another 30 minutes or so if anyone has any more detailed questions and would like to talk some technical implementation questions. And so for now, though, I'm going to just really quickly, right from the viewer, if you click the button, it brings you to the GitHub repository. So this is the GitHub repository. It's publicly available to all. github.com/ravis-nrel/ravis. And so it is a web application. The source code is organized here. The README includes some high-level documentation about the purpose of RAVIS for people who just would stumble upon this site. But more interesting, perhaps, to this audience is that in the table of contents, there are detailed instructions for, first of all, if you just want to get it started quickly, to take a look at some static data, as well as some advice for what happens if you want to deploy it to production. Similarly, for the web client, some advice for deploying the web client to production, some configuration aspects. Here we detail more fully the server-side APIs, how to configure the server-side code, We also detail the formats. And so I briefly touched on the point that any data can be ingested into RAVIS if it matches, if it's able to be formatted as JSON in such a way that RAVIS is expecting it. And so here we have documented those formats, plant formats, forecast formats, and there are, so on the main page README, we have all of this documented in the, under the subdirectory for the server side itself. There are more details as to the API points, API endpoints, and how to configure them, what their inputs are, what their outputs are, more detailed performance constraints. And so similarly, if you look in the client directory, you'll see again some more details specific to the client side code for getting it configured, getting it running, how the code is organized. And so these instructions would primarily be useful to software developers. And so the RAVIS system is not a turnkey solution. There's no way to simply run an installer and have RAVIS running. It's a sophisticated web application designed according to modern standards. Any software developer familiar with web development, dynamic web applications in the last 5 years would be able to easily understand these instructions and get it running. I would not expect that a layman would be able to follow these instructions and easily have success in running RAVIS locally. And I certainly wouldn't expect a layman to be able to successfully stand up a production deployment that was, free of bugs and performance issues. And so I wanted to mention that just so it's clear. We did not attempt, nor were we funded to attempt to generate a turnkey application that would be simple to simply install and have kind of a plug and play solution. And so I believe that is where I'll stop.